All right, let's do another Leetcode question. We'll do an algorithms easy and choose one at random. So let's pick one and start the timer. Okay, so we are doing number 2148. Count elements with strictly smaller and greater elements. Given an integer array of nums, return the number of elements that have both a strictly smaller and a strictly greater element appearing inside nums. So what does that mean? So for example 1, we've given 11, 7, 2, and 15. A 2 has, the output is 2 because the element 7 has the element 2 that's strictly smaller and 11 strictly bigger. And also element 11 has 7 smaller and 15 strictly bigger. Why isn't 7 also one of them? Because then there'd be 2 and 11, for example. What does strictly mean? -3, 3, 3, 90 has the output 2 as well, because 3 has the element -3 and the element 90. And there are 2 elements with the value 3. In total, there are 2 elements that have both a strictly smaller and greater. Oh, the element 7 has 2 and 11, and the element 11 has 7 and 15. Okay, never mind. That makes more sense. Okay, so is this the same as saying find the smallest and largest number and remove them and then count whatever's left? Would that ever fail? So kind of what I'm trying to think about is if we have some number one, A, B, C, and then, to N, is the answer always going to be the length of this array -2? No, because we might have the case that A and B are equal to each other. Or, n-1 equals n, or something along those lines, etc. So if we take the smallest element and remove all elements that are equal to the smallest element, or actually you iterate through the array, keeping track of the smallest and largest element, and if another element is not equal to either of those, and it's smaller, the smallest is strictly small and the largest is strictly larger, increment the count along the way, then that's one way to get the total output, the total number of elements that have both a smaller and larger. The only problem is if your first number is like here, the element 11, you haven't yet gotten a smaller or larger number for it. So you have to do a second pass through. So you could do one pass to get your smallest and largest element, and then a second pass to count them up. And that'd be one way to do this, perhaps. So let's try that. Let's have a look. I'm not going to actually implement it yet, because maybe we can do it better than this. First pass. Let's get the smallest and largest values, O of n time, O of 1 space. Second pass, count elements with smallest, strictly larger elements. O of n again, and O of 1 space. So this is technically an O of n time, O of 1 space solution. We can't ever do better than O of n time because the elements are not sorted, and can't do it better than O of 1 space because it's O of 1. Within the big O, we can start thinking about, can we do this in one pass rather than in 2? Could we store less than these number of elements? Is there any argument to be made for keeping track of the elements and in a hash table, for example, and then reiterating through them? No, I don't think that's faster. So Is this approach the correct way to do this? If the array was sorted, we wouldn't have to do the first pass. We'd know the smallest and largest is the first value and the last value. So that's one thing to keep in mind. And strictly small and strictly larger, I have to assume means can't be the same number. It has to be off by one at least. And these are all integers. Size of the array is given, not greater than 100, and the values of the numbers will fit inside an integer. These are kind of questions you'd want to ask your interviewer, whether you'll have like valid inputs, how big it could be, will it fit in memory, and so on. But with Leetcode, it's almost always the case. All right, I don't think I'd be interested to see if there's a way to get past this two-pass approach, but I think at this point I'd suggest to an interviewer that I'd want to implement this unless they want me to think about it more. So let's just say it's time to go. So let's create our function, and we'll call this count elements as it shows there. And yes, I know I'm doing this in a Google Doc instead of Leetcode. It definitely sucks, and I think I've heard that Google doesn't use Google Docs anymore. They might be using some sort of editor, so this might be the last few videos where I do this. But for now, we're going to try to use the input's nums, and the output will be an int for the number of values that are passing. We're going to keep using this for now because that is sometimes what you get when you get interviews, is you don't get access to an IDE, and you want to get used to being able to write code with a really crappy interface like this. I know you don't end up using that in real coding, but it does sometimes happen in interviews, so that's what you have to prepare for sometimes. And honestly, once you've done it a couple of times, it's not too hard to shoot through. Well, let's see. All right, so what I'd like to do is pass one, first pass. And we'll just do, let's keep track of smallest, and that'll be none for now, and largest is none. And in fact, we could have a check if of nums is less than 3. So there's a sanity check. If there's only 2 values or less, then return 0, because you can never have strictly greater and strictly smaller elements in the array. So now we know that they exist. Let's just start off with the first value, and then for num in nums, if num is less than the smallest, then we just replace it. And yes, there is faster ways to do this, but we will get to that in a second. For now, I'm just writing out in this the most straightforward way we can do it. So if num is greater than largest, we replace largest with that value. So we've done our first pass, and now it's time for a second pass. So now we want to count elements that are greater or smaller. So num in nums. If num is greater than smallest and num is less than largest, we want total equals 0. And so if this is has a strictly small and strictly larger value, then total plus 1, and then we can return total at the end. So this is our O of n and O of 1, and same for the first one. And I believe this should just... All right, are there anything we're missing here? Because we can shorten this in a minute if we want to, but I just want to get the base code out. We're checking for the edge case, so if the array is too small. Checking for the... Well, a question here also is, if there aren't enough elements, is it valid to say that 0 is the correct number of elements that don't exist? Strictly greater and strictly smaller. I think from the definition, yes. And it's possible, in fact, we might have nums length 1. Does this still work if there are numbers that are equal to each other? Yes, because we're doing 2 passes. In the second pass, we're actually checking that it's greater than and less than, and not greater than or equal to or less than or equal to. So I think this should be as is. So let's see, what are we looking at time-wise? About 9 minutes? Okay, let's try and run this. And the tabs, of course, are okay. All right, I think this should be all right. I'm just kind of looking through it right now, especially now with the syntax highlighting. Just making sure the if statements are all in line. Okay, let's have a look and see if this runs. Okay, passes the test cases. Let's have a submission. And it passes. All right, good to see. Don't worry about how long it takes. Usually for code that's this simple, most of the time is in the backend, kind of random, and any shortcuts that might be used. We can now have a quick look. So this was good for a quick warm-up question, about 11 minutes. Let's see if there's anything we can do to get it to be a little bit more of a one-liner. So let's see. What I'd like to do is kind of do a something along the lines of smallest equals min of, actually you can, well, can you do min of an array with Python? I don't remember if it applies to a generator. I think it does. So we can start with that and have a look. Technically this would become 2 passes. So so let's just pretend, let's actually see if this works. Min of num. I'm not sure if min works like that. It does. Okay, so you could technically do something along the lines of this right here, and you have gotten rid of writing the code for doing this loop, but each of these is a O of n. So now you're doing 3 passes this way. So it's not actually any faster, it's just a little bit cleaner to write. So that's one shortcut, for example, as long as you understand the thing that's going on here. Next is, yeah, let's keep that in. Here we could do some sort of inline iterator. So you could do the sum of for num in nums, and then the total equals that. I think that is one way you could shorten this up. And this basically just sums up wherever the Boolean value returns true. So let's try that out and see if that works. Yeah. And even though this is technically algorithmically more inefficient, let's have a look and see what the backend does with this. Yeah, see, it thinks it's fast. It is faster just because there's some optimizations going on here. When you run min on an array, it's able to run that through the C-type backend. But in terms of like algorithmic efficiency, there's more passes going through on these two. Either way, pretty cool little problem. I hope that was interesting to all of you, and see you guys next time.